My title is Assessment for the Water Contributions of Urban and Forest Non-Point Sources in the River Water Quality Assessment, a case study. As we discussed yesterday and today, that several presenters mentioned about the non-point sources and as well as point sources. So basically, at present, due to the technological advancement and the awareness of the pollutants, society is very well understand about the point sources. However, non-point sources are still not identified properly. Even though identified, they are not controlled properly everywhere because they are very difficult to trace, monitor and manage. And mainly we can categorize, we can find non-point sources in fertilizer applications in agriculture, livestock and atmospheric deposition and urban areas also. And the significant feature of non-point sources is it happens during rainy season, or it can be high wind season, windy environment, or in kind of it is not continuous discharge of pollutant or anything like that. So if we think about the status of water quality watershed management today, in the early industrial region, industrial era, so point sources were dominant because of lot of factories came up, and however, due to technical advantages, we were able to control that one. And later on, in early 90s or mid 90s, then we found about non-point sources. But non-point sources are controlled in the present cases like BMPs, we call best management practices. But however, in still developing countries and developed countries, it is not controlled 100%. So in our study, we try to develop a model to tackle and see how non-point sources contribution to river water quality. In our study, we selected one of the river basin in Japan, and that river basin is located in the Lake Inbanuma watershed. Lake Inbanuma is one of maybe the third or fourth largest lake in Japan. It has a bad reputation of water quality in 1970s due to a lot of nutrient loadings. However, due to restoring and life sustaining lake plan initiated by Inbanuma Lake Committee, recently that water quality has been improved. These are some of the facts about the lake Inbanuma. And if we think about the long-term change of loading by different sources, so in these two figures we can see the total nitrate and total phosphate loadings for the Inbanuma lake. So you can see from 1985 to 2010, there is a significant decrease in the total loading of nitrate phosphate, especially storage and industrial. We can see kind of decrease. However, still urban areas and farmlands we couldn't see much. We cannot see much decrease. So and then. This is the Inbanuma lake basin. So our target to our study area is this Takasaki river basin. It is a small river basin, about 85 square kilometers. The total population of here is about 94,000, and the land use is mainly consist of agricultural area like paddy or farmlands and some urban areas here. And the storage systems and deterioration of water in the river, lake and urbanization are the kind of issues in this basin, and the point source pollution has been decreased. However, still non-point source pollution is still remaining as an issue. And these two figures shows the loadings to the Takasaki river basin, and we can categorize different sources like storage, industrial and non-point sources. So you can see the loadings from non-point sources are significant, especially in the farm and livestock urban areas. The significant loadings are coming from those sources. And these different colors shows different main cities in this basin. There are 4 main cities, and Chiba prefectural government, the prefectural government which this lake is located, has developed this graph for 2008 loadings. And as I mentioned, the non-point sources are very dominant during rainfall event. So these figures give some idea about how these pollutants happen. For an example, this is one of the rainfall event. So you can see with the discharge, the nitrate and phosphate loadings are increased. So this in this one also you can see with the discharge, river discharge, how the contents of nitrate and phosphate loadings are increased. So mainly this kind of phenomena can happen because of the non-point sources. And the application of the simulation model. So as I mentioned that pollution loadings from point sources has decreased by improvement of treatment facilities and storage system and rules and regulations. The loadings during rain season make up the majority of the total pollution loading. So it is important to clarify the characteristics of pollution loadings during rainy season, mainly the non-point sources. So in our case, we develop a numerical approach to study these areas, this phenomena. So to identify the critical pollution sources, establishment effective countermeasures and future forecasting are the target of our numerical model. So for that one we selected web model. Web model is water energy transfer processes model. It was developed as a hydrological model. Later on it was updated to simulate the nitrate, phosphate and suspension loadings also. So it is really complicated model. This figure shows the hydrological aspects of the model. It consists of surface, subsurface and deep aquifer. These are the main systems of the model. So in this part, it's deal with the energy processes like solar radiation and evapotranspiration, lot of processes. This is the kind of vertical structure of the wave model. And these are the features of different features of the model. So I will skip this slide. So in the hydrological part of the model, these are the main processes model deal with evapotranspiration based on Penman-Montague equation and surface flow in unconfined aquifer, confined aquifer, and the river and groundwater interactions. And the infiltration is deal with the Richard equation if the rainfall intensity is lower than the vertical saturation, and if the rainfall intensity is greater than the vertical saturation, then it is Greenland equation. And river routing, we will deal with the kinematic equation. And these are the model inputs. We can categorize meteorological data, geographical hydrological data, then anthropological activities and water quality simulations. So it is a really complicated model.
You accelerate a little bit.
Okay. So okay. So in the point sources, we use the unit load method to assess the loadings. And for the non-point sources, we categorize like forest, urban area, and agriculture as our main non-point sources. So these are the equations we use for the non-point source assessment. And this is for the agricultural farmlands. This is the conceptual model we developed for the non-point source pollutant transport. We categorize nitrate as dissolved nitrate and particulate nitrate, phosphate also dissolved, and particulate phosphate, like that. And so these are the parameters. So finally these are the results for the 2005 results. So I think for the hydrological model it generates reasonably well results. compare with the observation ones. And our main observation point is located here, so this results for that one. And these are simulation results for total nitrate and total phosphate for 2005 whole year. And there are two rainfall events. So we simulated for that rainfall events. Our results shows a very significant improvement after calibration for these two events for total nitrate and total phosphate. And then to study each land use, so we selected small basins in our basin. So this basin has a majority as urban and this is as forest. So these are the results for each sub basin. So small sub basins, our results are not so good. So because that one we have to tune parameters like localized parameters. So that one is really complicated. Now I am working on that one. So these are another set of results for same location. So I think I can
okay.
stop this.
Thank you. This is very, very interesting results, and I would like to open one or two important questions. Please go ahead.
Thank you very much. One, how would you consider to be the limitation of mode application?
Sorry?
How would you consider to be the limitations for applying this model? And then number two, how would you assess the model efficiency?
First question, what is invitation? What?
The limitations for application of the model.
Limitation. The shortcoming.
Yeah, I think we assessment of the model, because we calibrate the model. I think I saw the results like this. So these are the calibration.
We can discuss it later.
Okay, let's another question, final question. Yeah, if not, I think that the calibration process is very, very important. This is the kind of the topic, kind of modeling. But my concern is, can you apply this scale into the big scale, and what parameters should be changed for the testing?
Yeah, I think so far we have applied for like micro, very small basins. So far we don't have any experience with the very large basins. So because that I cannot.
Yeah, I think I thought that ICHARM can apply for the all over the world using this modeling, but it will gonna be very important. Thank you.
It is true, but it is really complicated, like because a lot of parameters to it.
Okay. Okay, so let's finish the presentation. Thank